evaluate limit using table values. Let's do it. The first function is f of x equals to x squared plus 3. I am trying to use this table to find out what the limit equals to. So I have x equals to 2. So if you plug in x equals to 2, you have 2 squared, which is 4. 4 plus 3 is equals to 7. So that is equals to 7. How about if you pick some x value that is a little bit less than 2 and some values that is slightly greater than 2? So when x is equals to 1.9, you square 1.9 and then you add 3 to it, that is equals to 6.61. X equals to 1.99, you square that, add 3 to it, you have 6.9601. X equals to 1.999, square that, add 3 to it, you have 6.996001. How about 2.001? 2.001, you have 7.004001. And then when x is equals to 2.01, we have 7.0401. X is equals to 2.1, we have 7.41. So as x approaches to 2 from the left, what do you have? X approaches to 2 from the right. So this is left side. Left side means x slightly less than 2. Right side means x slightly greater than 2. What do you have? We can see that the y's are so close to 7. So as a result, the limit is equals to 7. Then you might ask me a question. All right, so why don't you just plug in 2 to the function, square that, add 3 to it, you'll get a 7. Yeah, that's fine. That is the right way to do it, but that doesn't work every single time. For example, the next problem, if you just plug in 2 to the function f of x, you have 1 divided by 2 minus 2, which is 1 divided by 0, so that is undefined. So in the next problem, when x is equals to 2, there is no y value, so that is completely undefined. So in that case, we have to pick some x value that is slightly greater than 2 and slightly less than 2 to see what happened. All right, 1 divided by x minus 2. And then when you evaluate this using your calculator, make sure you have 1 divided by x minus 2 in a parenthesis. Otherwise, you will have 1 divided by x first, and then you subtract 2, which is wrong. You want to do the subtraction first and then perform the division. Okay, when x is equals to 1.9, when x is equals to 1.9, we have y equals to negative 10, and then 1.99 minus 2, 1 divided by the difference, you have negative 100, and then this is negative 1000. And then on the other side, when x is equals to 2.001, plug in, you have 1000, and then this is negative, not negative, that is a positive 100, and then a positive 10. So this time, x approaches to 2 from the left, x approaches to 2 from the right. What happened? So as x approaches to 2 from the left, it looks like we have a negative infinity. The y is getting so big and negative. As x approaches to 2 from the right, the y is getting so big and positive. So we have one negative infinity and positive infinity. So since they are not equal, I will just say the limit does not exist. Let's take a look at the graph, although this is a table value problem. So we have x-axis, we have a y-axis, so we have x minus 2 in the denominator. So therefore, x equals to 2 is a vertical asymptote. And then on the left-hand side of the vertical asymptote, this is the graph. And then on the right-hand side, this is the graph. Okay, so as x approaches to 2 from the right-hand side, do you see that the curve goes all the way up? So it goes all the way up like that. So that means y approaches to positive infinity. That is another way to write this. Limit as x approaches to 2 from the right, and then f of x, y approaches to positive infinity. So this is another way to write the limit. Left side, as x approaches to 2 from the left, y approaches to negative infinity. So you have a positive infinity and a negative infinity. So that means what? That means the limit is does not exist. So that's why I write DNE. DNE stands for does not exist. Next, we have an absolute value of x divided by x. So if you plug in a negative 0.1, so you get a positive because of the absolute value. So it looks like for the negatives, you have a positive divided by negative. So this will be all negative 1. When x is equals to 0, you have 0 divided by 0, which is undefined. And then on the other side, you have a positive divided by positive, which will be all 1. So as x approaches to 0 from the left, y approaches to 1, negative 1. As x approaches to 0 from the right, y approaches to positive 1. So since they are not the same, that means the limit does not exist. How about the first one? The first one is as x approaches to 2 from the left and from the right. So as x approaches to 2 from the left and as x approaches to 2 from the right, the y value, they are both approaches to 7. So since they are both equals to 7, then the limit is equals to 7. So in other words, in order to have the limit defined, the left limit and the right limit, they must be the same. So that is one thing that we learn from this problem. That is at the end of this video. If you think my instruction is helpful and clear, give me a like, share the video for me, click the subscribe button if you're on your way out. I will catch you all in the next one. Signing off for now.